Hello and welcome to this latest episode of LBTV. I'm your host, Mark Jeffries, and today you're going to learn how to achieve agility with load balancers and specifically how Arvi can support you in this journey. You know, VMware was brilliant to bring Arvi networks into the mix for load balancing, as it was designed as software from the beginning. That sets Arvi up for a host of advantages. The architectural approach of separating the control plane from the data plane sets up Arvi for single point of control across hybrid environments, while harvesting actionable analytics for troubleshooting, which, as you know, is a massive win for IT teams. This is done as it sets up for automation, which allows auto-scaling, self-healing, and agility. Let's take a listen to Nathan McMahon, the Director of Enablement Programs at VMware, and learn how to spin up and deliver a new application.
This enables us to do things like have that controller be delegated to it and say, I want to go and spin up an application, and the controller is going to say, great, which load balancer, which service engine do I want to deploy this on? Does it have enough capacity? If not, then go spin up some new service engines. If I have excess capacity, let's tear some down or spin them in. So it can spin up and down capacity, it can elastically scale on demand, it can self-heal if a service engine fails. So that elasticity is all automated, and you're just telling the controller, I want to deploy an application, and then you let it figure out what it needs to do to make that happen. Now the controller, it sits out of band and manages the service engines for you. The service engines can then be deployed in whatever environment that you're deploying your applications into. So this can be on bare metal virtualized container, on-prem, public cloud. It really doesn't matter. These service engines can be deployed in any of these environments and still be managed from one single point. So if you're looking at multi-cloud, how do I normalize this? I can send a single call to the controller saying, I would like to make a change to this application. Where is the application? It may be in 2 or 3 data centers. It may be in a container, it may be in virtualized environments, all at the same time. That's okay. I just tell the controller, this is the change I want to make to my load balancing configuration or to my WAF policy. And I don't have to deal with the details underneath that.
It's true. By utilizing the controller, you're able to increase your efficiency, agility, and productivity, all while decreasing the number of manual steps. Sounds like a no-brainer, right? Well, that's because it is. Now, let's listen to Nathan's radio voice to find out how else the Arvi controller can support day-to-day businesses.
So the controller's sitting out of band. It has all day long to process a lot of data that's input from it. So the service engines don't have a GUI, they don't have any management, but they are a full application proxy. They see all traffic that flows through them. So they're able to take a metadata of the client interaction with the site and feed that back to the controller. So the controller is ingesting about 700 data points per application or per virtual service, and that generates as much as billions of data points per day, logs, analytics, and the controller is able to take this instead of just showing you raw data and show you something that's actually useful, actionable insights and information. And the controller is essentially doing that big data analytics, and this is really, really useful for things like troubleshooting, but this is also very useful for automation.
The Arvi load balancer is able to talk to many environments through a single control point. So instead of having multiple pairs of active standby load balancers, what they have is a fabric. Now, this fabric is fluid. It scales up, scales down. It moves around, deployed on standard x86 servers or virtual machines, depending on application needs. It works with you and for you by delivering application services close to the application in any infrastructure. Arvi is saying the old model of active standby pairs does not scale and is often wasteful. It's not aligned with how applications are moving towards decentralization, running in containers. The need to spin up capacity on the fly is pushing load balancing into a cloud-native infrastructure as software space. Now let's see what Nathan has to say about managing the applications, the fabric that delivers them.
I'm dropped into an Arvi controller. From the controller, I've got a complete ability to manage the Arvi infrastructure, the Arvi fabric. So I'm managing all of my applications. I'm not managing my individual service engines, the data plane component of the load balancer. Yes, they all exist, but it's a little bit of a different paradigm shift here. Here's a list of all of my applications. Are they green and happy and healthy? And if not, let's explore why not. On the right here on this column for cloud, some of my applications are deployed in a VMware vCenter environment. Some are in AWS. This one's in Azure. They can be deployed in different data centers, different environments, different clouds. And where those applications are deployed is where my service engines will also be instantiated. But I'm managing all of this as a single infrastructure or a single fabric from this one UI.
Seems like a huge benefit to really manage load balancing across hybrid environments from the same controller. Arvi is big on analytics and visibility. This is a huge reason many customers want to give it a go. Now, let's see a snapshot of this in action.
Arvi's default view of the world is not bits and bytes or packets per second. I'll show you the 6-hour window here. Our default view of the world is the end user experience. And what this is showing is that at whatever point in time I select here, this is saying that clients are taking about 33 milliseconds to connect over the internet to our load balancer, about 2 milliseconds for the server to pick up the connection, 38 milliseconds for the application to process this, 27 milliseconds to transfer it. So the round trip time is about 100 milliseconds. If somebody calls in and says, hey, the site was slow a few hours ago, yes, it was. And we can look at this big spike in time here. And the big spike here is primarily from the application response, meaning the applications took nearly twice as long to generate the content at this point in time. Arvi's collecting, like I said, about 700 data points per application, events, metrics, etc. You can take action on these, automatically scale out your backend application servers. You can automatically scale up Arvi's capacity on the service engines if you're required. You can go make API calls to external systems. There's a lot of power and capability that's here, in part because we have access to so much data, but we're not just giving you raw data points. How many bits have traversed the load balancer since we turned it on 4 years ago? We're saying there's actually a problem here. So our health score is saying there's an issue. This is showing us a little more about what the issue is, that mean time to innocence. I can look at this and immediately tell you, yep, that's an application problem, not a network problem. Let's hand it off to the network team, or to the app team.
That really looks like a cleaner, more agile way to troubleshoot. All right, let's now switch gears and discuss what it's like to spin up a new virtual service in a software-defined load balancing world with Arvi. What load balancer should I deploy on? Where is open capacity? These questions and more are answered by the Arvi controller. All you need to do is set up the parameters to work with and delegate the decision making. Wait, what? Did you just receive help to get work done faster? Yes, you did. One administrator can handle 10 times as much infrastructure as with previous hardware-based load balancers because of delegating to the controller. This is just out-of-the-box functionality and a must-have in today's application-driven businesses. So now you want to create a virtual service. Let's bring back Nathan so he can show us how to get that done.
So we're able to really start stitching together and chaining together services like IPAM, DNS, maybe SSL certificate creation, etc. So I gave it a name, told it I want network 1, and then down here I'll type in the list of all of my servers, which is not what I'm going to do because that's really slow. So I'll click on select servers by network. And what happens is in this pull down menu, here's a list of all the networks where I may have servers. This list is coming from, in my example here, Amazon, but this could be Kubernetes, this could be vCenter, this could be Azure, etc. The Arvi controller is making an API call to these environments, to these other clouds, to say, here's the list of networks that we have that you have access to. All of my servers are on the private AZ1 network, so Arvi makes another call and says, show me the list of all the servers in that network. So I want server 1 through 4. Great, add servers. I didn't have to know what their IP addresses were. I don't care what their IP addresses are. If they come, they go, they change. Great, I don't want to know. So I created a new virtual service. I said, pick up an IP address in public AZ1, and my servers are named 1 through 4. Hit save. And now that I've saved this, Arvi's going to take this configuration and it's going to place it onto a service engine. So it's going to decide for me, of all of my load balancers in my environment, which one do I want to deploy this onto? So I may have one load balancer, I may have 1,000. It's going to go and look and see who has the most capacity, who has reachability to these networks, guarantee anti-affinity, make sure all of that is good. And if that's good, then my application got deployed onto this service engine.
Well, that seems simple enough for launching a new virtual service, but how would it look to do an upgrade?
We can do this without any loss of packets. Very seamless. We can also, though, when we do this upgrade, we can upgrade just one environment, maybe just upgrade one data center or just upgrade one tenant. So if we want to upgrade the lab applications from version 1 to version 2, great, but don't impact production. We want to keep those on version 1 for a while longer until we're confident. Very, very cool stuff that you can do with Avi. So even though it's one cohesive fabric, it is something where you can have this be treated differently on a per tenant basis or per applications, etc. So there's a lot of capabilities that are here, which is pretty cool.
This is all about working smart, not hard. That's why automation is built into Avi to support various pain points, including auto-scaling for capacity, which can really help. Now, let's see how auto-scaling works. Nathan has an interesting way to show how the system would auto-scale.
You can have Avi deployed in a fully automated and auto-scale mode, but then it would have already scaled out and there wouldn't be anything to show you. So instead, this is deployed in a manual mode where I have to click the Scale Out button. So what this means is I'm right now running in this service engine, ILCAS, click Scale Out, and I'm going to skip the options and just say, just go do it. So if one service engine was running on a 10 gig NIC, I had 10 gigs before, now I've got two service engines. This application can now push 20 gigs of throughput, or whatever my load generator can push. There's this little icon down here. It's saying configuration event and action scale out was executed by Nathan. So there's a record of what happened. And now you can see traffic is going along, and now traffic is spiking up. Not much of a spike, but my load generator now is able to send it more traffic because I now have more capacity to handle more load. It's fairly straightforward, fairly simple. I'm now running active-active across two service engines and distributing traffic across them.
So you're not really managing devices, nor are you managing individual load balancers. You're managing a fabric. You're managing applications, not service engines, so it doesn't matter if you have one service engine or 1,000. This really helps as you scale, and the gap from lab to production needs to be closed. Let's look at Nathan's analogy to help visualize.
So in this example, I've got a fleet of taxis running around town doing whatever they do. A centralized manager can tell you the status of your taxis. Yep, this one's working, this one has gas, this one isn't working, this one has a passenger in it. But let's say a passenger wants to get picked up. Centralized manager's like, I don't know which one to use because they're all in use. Well, which one's the next one that's going to be available? Which one, start thinking ahead, start actually thinking about this. Centralized managers doesn't think like that. We're going to need a whole bunch of taxis at this part of town at this point of time. And we can know that in advance because that's what happens every day, every week, etc. Every Friday night, everyone's at the bars. They want to get picked up at midnight. Let's move our fleet over there in advance. With a centralized manager, they know about the existing condition of things, but they don't have the ability to really take action.
Ah, yes, that was a great analogy and really brought the technology to life. So if you're centrally managing and one component goes down, what does that look like? Can it self-heal? Well, let's go back to Nathan and see how we can go from failure and recovery.
Go and whack one of my load balancers. Hopefully this is something you do often, just to check to make sure everything is working, your HA works, etc. You just periodically just go and pull the power plug out of your active load balancer, right? It's definitely something people should do, and of course nobody ever would dare do that because, well, what if it failed? Well, that's kind of the whole reason why you test. And so what's going to happen with our service engines when that gets shut down on Amazon's side, we're going to see that this is going to turn to red. There we go. Heartbeat failed, and poof, that one's down. Now what's going to happen is that my application is no longer meeting its HA. That's great. It's still up and it's still live because it was running active on 2. So my application is still doing good, but now it's just running on one load balancer right now. And I've got a fault detected is what it's saying. This little slash through it. And it's saying I need 2 service engines, currently only 1. If I go back into my infrastructure, what's happening is that literally within a second, the controller is saying, oh, I detected the failure occurred. One of my service engines went down. It's not available. In fact, it can actually even tell you what's happening about it. Oh, failed to health check. So in the meantime, what I'm doing is I'm spinning up another one to replace it. My application's still up and still live, but the controller is self-healing. And I've got this new load balancer. Now it's spinning it up. It's waiting for it to connect to controller. And the status will change as it keeps hitting each of these milestones, configuring the next, pushing the config down to it. So it'll take, depending upon the environment that you're in, and do you have SSD, do you have disk? In a virtualized environment like this, like in Amazon, it'll take about 3 minutes or so to spin up a new service engine. I can go back a few years, and it used to take, with hardware load balancers, it would take people a week to go and deploy a new load balancer, or weeks even, to go and get the thing shipped out to a remote data center, fly out there, a lot of work. And this is in a virtualized environment. If you're doing this in a containerized environment, it takes about 20 seconds or so to spin up a service engine. It's really quick.
This automation, self-healing, and the ability to auto-scale is driving more and more enterprises to reach for software-defined load balancing. It also tackles the over-provisioning problem and controls costs. Now, before we go, let's hear a real-life customer story and see how they were able to achieve agility with load balancers.
It's going to take us a year to do an upgrade. That's not okay. It's going to take us an hour, and we're going to have all of our 1,000 virtual services or service engines, have them all running the latest version. That's what we want to see, is that when vulnerabilities happen, how quickly can you react? That's moving at the speed of business. And that's a bit of what Avi is all about. That's how we're differentiating ourselves from the F5s of the world, and these kind of second generation load balancers that are really built around the web, the database. The world's moving into public clouds. The world's moving into containers. The world's moving into microservices. Networking is changing because compute is changing. So since the compute's changed, you're not going to slow that down. Networking has to adapt. That's why you're seeing things like NSX, with the ability to automate the process of layer 2.3. But if you're going to automate layer 2.3 and not automate layer 4.7, what was the point? So that's what Avi's about. Avi is just that. Avi is the ability to automate layer 4 through 7, be more efficient, and provide you better capabilities. We make it faster and easier to troubleshoot, faster and easier to deploy applications, faster and easier to deploy service engines.
This has been really insightful, both hearing and seeing how impactful load balancing can be on your business. For more information, you can visit rvnetworks.com/load balancer refresh F5 or sign up for one of the VMware hands-on workshops at rvnetworks.com/workshops. I'm your host, Mark Jeffries, and I'll see you on the next episode of Load Balancer TV.